Welcome to Spaceverse, your portal to cosmic adventures. What if you could gaze back in time, not hundreds, not thousands, but billions of years, to witness the universe just as it was being born? Well, now you can. With the help of the James Webb Space Telescope, or JWST, astronomers have unveiled the most detailed view of the early universe we've ever seen. This isn't just a few distant galaxies glowing faintly in the darkness. What we're talking about is a massive cosmic panorama, a breathtaking sweep of the sky that brings us closer than ever to understanding how the universe looked in its infancy. And this isn't only for scientists. Whether you're a seasoned astronomer or simply a stargazer who loves the mysteries of space, this discovery offers all of us a front-row ticket to the ancient cosmos. The images come from Cosmos Web, the most ambitious observational campaign conducted during JWST's first year of operation. And when we say ambitious, we mean it. This project covered the largest area of the sky the telescope had ever observed in a single survey, an area so wide it could fit 3 full moons side by side. Over 10,000 individual exposures were combined to produce this record-breaking scan, revealing more than 800,000 galaxies, many of them dating back to just a few hundred million years after the Big Bang. That's 800,000 entire galaxies, each one potentially containing hundreds of billions of stars. And for the first time, astronomers have created JWST's largest ever contiguous image, a seamless cosmic photograph that stitches together all these observations in stunning detail. Even better, they've made the data public. That means anyone, even you, can explore this incredible image through an interactive catalog describing the individual characteristics of each galaxy. Released on June 5th, this is more than just a collection of pretty space pictures. This is a cosmic archive, a time capsule stretching back billions of years. Dr. Jayan Kartal-Teep, an astrophysicist at the Rochester Institute of Technology and lead researcher for Cosmos Web, said, "I don't know if the James Webb Space Telescope will ever cover an area of this size again." She believes this dataset will serve as a vital scientific reference for years, maybe even decades to come. And here's why. The Cosmos Webb team is made up of nearly 50 researchers from universities across the world. They were granted over 200 hours of telescope time, the most awarded to any project during JWST's first year after its launch in 2021. While many JWST studies zoom in deep into a small patch of sky, Cosmos Webb did the opposite. Instead of depth, they focused on width, scanning a wide cosmic landscape to uncover far more galaxies than astronomers expected. In fact, the project revealed 10 times more galaxies from the early universe than scientists had originally predicted. Dr. Maximilian Franco, an astrophysicist at the University of Hertfordshire in the UK, put it simply, it was incredible to reveal galaxies that were previously invisible at other wavelengths, and very gratifying to finally see them appear on our computers. And what makes this even more exciting is JWST's wide field of view. It allows scientists to study galaxies not just individually, but also in relation to their cosmic neighborhoods. Are they isolated? Clustered together? Surrounded by other galaxies? These surroundings can drastically influence how a galaxy forms, how it grows, how bright it gets, and what shape it takes. Kartal-Teep and her colleagues are using these insights to figure out what shaped galaxies over billions of years of evolution. And they've already begun publishing what they're finding. One study, released on June 4th through the preprint archive Arxiv, dives into the brightest galaxies inside galaxy clusters, exploring how their structure and star formation evolved over a staggering 12 billion years. But how exactly is the James Webb Space Telescope able to uncover such breathtaking detail? It's all thanks to its powerful suite of instruments, particularly NIRCam, the near-infrared camera, which can detect the faint glow of galaxies from the earliest epochs of the universe. By observing in infrared light, JWST can pierce through cosmic dust that once obscured our view, revealing structures invisible to previous telescopes. Combined with MIRI, the mid-infrared instrument, astronomers are able to detect cooler, older stars and even analyze the chemical composition of distant galaxies. This multi-wavelength capability is what makes JWST such a game-changer. It doesn't just take pictures, it tells stories hidden in starlight. And what sets Cosmos Webb apart from other JWST projects is its scope and strategy. While many studies zoom in deep, focusing on a single patch of sky, Cosmos Webb expands outward, offering the widest survey ever done with JWST. That means we're not just seeing a few examples from the early universe, we're seeing patterns. Evolution on a grand scale. This bird's-eye view allows astronomers to study the large-scale structure of the universe, the cosmic web itself, how galaxies cluster, spread, and evolve in their environments. It's like comparing a single tree to an entire forest. And thanks to Cosmos Webb, that forest is now clearer than ever. Another major focus of Cosmos Webb is the reionization era, a mysterious chapter in cosmic history that occurred about 13 billion years ago, when the very first galaxies began to shine. Back then, the universe was filled with dense clouds of hydrogen gas. Light couldn't travel far. It was a cosmic fog. But then, stars ignited. Galaxies formed. Their light began carving out enormous reionization bubbles, clearing the haze and allowing light to travel freely. The Cosmos Webb team is using galaxies as tracers, mapping out where these bubbles formed and how large they became. This will help them piece together how the early universe went from opaque to transparent. Kartal calls this one of the main scientific goals of the mission. Though they haven't finished mapping the reionization bubbles just yet, the excitement in her voice is clear. That was the main goal and something that we're really excited about. But that's not all. Alongside these scientific papers, the team also published research on machine learning models that estimate a galaxy's physical properties from the dataset. They even introduced a new way to measure galaxy brightness with higher precision. Traditional methods just add up the light inside a fixed area. But that doesn't always capture how brightness varies across an entire galaxy. So instead, their method simulates how light is distributed throughout the galaxy, giving astronomers a much clearer, more accurate reading. This even allows them to combine JWST's ultra-sharp images with ground-based data, which might be lower in resolution, without losing valuable information. Now imagine trying to align and clean up over 10,000 images, each with its own quirks, distortions, and noise. It took the Cosmos Webb team 2 years to carefully process the data. This meant dealing with unexpected issues like strange noise patterns and minor image artifacts. After all, JWST is still a new observatory. It came with its own learning curve. Yet, despite those hurdles, JWST blew past expectations. The reality turned out to be better, said Kartal. We were able to go deeper than what we expected. The team now holds what Kartal calls an incredible catalog of data. A catalog that captures a cosmic story billions of years in the making. But it's only the beginning. As she reminds us, there's still so much we don't know. The James Webb Space Telescope is not just a telescope. It's a time machine opening a window to the earliest light in the universe and offering us a glimpse of where we came from. The discoveries made through Cosmos Webb will inspire a generation of new questions, new theories, and new missions. So whether you're a scientist, a student, or just someone who looks up at the night sky and wonders what's out there, keep your eyes on the stars. Because the universe is just getting started. And if you enjoyed this journey through space and time, don't forget to join us here at Spaceverse, where the cosmos comes alive. Subscribe for more deep dives into the wonders of the universe, and hit the bell so you never miss a launch into the unknown. Thanks for watching. Until next time, keep exploring. The stars are waiting.